Hello everyone. Today I will be discussing the AC sine wave in relation to electrical engineering. AC stands for alternating current, but we also use alternating voltage when plotting AC sine waves. When we plot alternating currents or voltages using a waveform function, we use the sine wave function because it shows how current or voltage changes over a set period of time as they alternate between positive and negative values. Let's analyze the properties of an AC sine wave. A cycle of a sine wave is where the waveform starts to where the waveform repeats itself. After 2π, this waveform would repeat itself. So what we see here between 0 and 2π is considered one cycle. An alternation is half a cycle and is where the wave alternates from the positive to the negative, back to the positive, then to the negative, and so on, as it keeps repeating. The peak value of a sine wave is the top and bottom Y values, which represent the positive and negative peak voltage or current. The peak-to-peak voltage is the value between the highest and lowest peaks, or simply double a peak. The average of a full sine wave is all the Y values of the wave divided by the amount of times we add the Y values together. For one sine wave, this would give us a result of 0. However, the average of an alternation can be determined using 63.7% multiplied by the peak value. The instantaneous value of a sine wave is also known as any point on the graph in which you would like to determine the Y value, or rather the current or voltage at a certain point. To find the instantaneous current or voltage, we must calculate using the sine of the angle multiplied by the peak. In the example above, I can use the formula to find y, which equates to the peak, which is 1, multiplied by a sine of 135 degrees. This gives us approximately 0.7 volts or amps. Finally, we have the effective RMS value. This is the AC current or voltage heating value, which gives the equivalent steady DC or direct current value that has the same heating effect. In a sine AC graph, this is found using 70.7% multiplied by the peak of the graph. In the example to our right, we can find the RMS by multiplying the 23.4 amp peak by 70.7%, which will give us around 16.5 amps.